Kawasaki has unveiled a remarkable innovation that could redefine both robotics and transportation: the Corleo robot vehicle. Revealed on April 5, 2025, at the Osaka Kai Expo, this hydrogen-powered, horse-inspired machine is more than just a futuristic concept. It's a real-world breakthrough in mobility and environmental technology. Built to traverse difficult terrains with grace and power, the Corleo embodies a major leap forward in how robotic systems interact with the environment. What sets Corleo apart is its fusion of cutting-edge engineering and animal-inspired design. It doesn't resemble traditional vehicles or typical robots. Instead, it moves like a four-legged creature, engineered specifically to handle real-world landscapes: snow, rocky ground, forests, and steep inclines, with natural, fluid motion. Its hydrogen fuel system ensures not just long-range capability, but also zero-emission operation, presenting a sustainable alternative to fossil fuel-powered machines. Unlike robots built on wheels or tracks, Corleo walks, leaps, and runs. Its four legs are independently powered by precision electric motors that give it a level of agility and control not seen before in large mobile robotics. Mimicking the movement of a horse or big cat, the robot can adjust its gait depending on the terrain, enabling it to maintain balance and speed even on surfaces that challenge conventional transport. The secret lies in its legs and hooves. Each leg ends in a specially designed hoof made from an advanced rubber compound capable of gripping a wide range of surfaces. These hooves contain embedded sensors that detect the material and texture of the ground, allowing the robot to instantly adapt its footing. Whether it's walking across ice, loose gravel, or slippery grass, the robot maintains stability with remarkable precision. Beyond mobility, the suspension system integrated into Corleo's frame helps absorb impact from uneven ground. This not only improves ride smoothness, but also enhances long-term mechanical durability, a key factor for any technology intended for harsh conditions. The interplay between leg movement, terrain awareness, and suspension results in a robotic platform that feels less like a machine and more like a living, thinking creature. Powering this innovative robot is a hydrogen-based energy system. Instead of relying on batteries that need long hours of charging, the Corleo uses hydrogen fuel cells to generate electricity through a chemical reaction with oxygen. The only byproduct is water vapor, making it an incredibly clean energy solution. This approach also allows quick refueling, just a few minutes, compared to the extended downtime required by electric vehicles. Hydrogen as a fuel source gives the Corleo an impressive range of up to 150 miles on a single refuel. For applications that demand extended travel across isolated or hard-to-reach areas, this efficiency is a game changer. Kawasaki's integration of hydrogen into this project is not just about energy innovation. It's a clear signal that the company is serious about aligning robotics with the urgent need for environmental sustainability. Energy density is another critical advantage. Hydrogen fuel cells store more power per unit of weight compared to lithium-ion batteries, allowing for lighter design and longer operational periods. This makes hydrogen particularly well-suited for high-mobility robotics like Corleo, which must remain both agile and enduring. Kawasaki's creation isn't just about impressive engineering, it's about real-world impact. Corleo has the potential to reshape multiple industries. In logistics, it could revolutionize how goods are transported in remote or rugged regions. Where trucks or drones may struggle, Corleo can deliver supplies, materials, or emergency aid efficiently and reliably, cutting through obstacles that previously limited access. In agriculture, it could take on tasks from hauling tools and supplies to helping monitor crops across expansive, uneven fields. Its ability to operate autonomously on land that tractors or human labor find difficult to manage opens up new possibilities for farms in mountainous or forested terrain. Tourism is another field where this technology could shine. Imagine guided tours through wilderness areas or eco-resorts using robotic mounts that allow visitors to explore without damaging delicate ecosystems or relying on fuel-heavy off-road vehicles. The Corleo offers a low-impact, high-tech way to bring people closer to nature without compromising sustainability. Kawasaki's design reflects a future where robotics are not just functional, but deeply integrated into the natural world. By borrowing movement from animals and combining it with clean energy, the company has taken a major step toward a new paradigm in mobility. The Corleo is more than a demonstration of technological prowess. It's a bold vision of what comes next. Tourists could soon explore remote mountains, dense forests, and other hard-to-reach natural environments without traditional off-road vehicles, thanks to Kawasaki's innovative Corleo robot. Designed to traverse rugged terrain with ease, the Corleo offers a new and thrilling way for people to experience the outdoors. Whether it's a guided nature tour or an off-road expedition, this robot could redefine ecotourism by combining adventure with minimal environmental impact. Beyond leisure, the Corleo could serve critical roles in disaster-hit areas. In the aftermath of earthquakes, floods, or wildfires, it could deliver essential supplies, assist in rescue operations, or support cleanup efforts, especially where conventional vehicles can't reach. Its agility and reliability in difficult conditions position it as a powerful asset for emergency response teams. Its potential doesn't stop there. The Corleo's versatility, maneuverability, and eco-friendly hydrogen power make it a strong contender across multiple sectors, from agriculture and logistics to defense and infrastructure maintenance. It may well represent the next frontier in clean, adaptable, and intelligent mobility. However, the journey from prototype to widespread deployment is fraught with technical and practical challenges. One of the primary obstacles Kawasaki faces is scaling up production. Creating a few impressive prototypes is one thing. Manufacturing thousands while maintaining quality and performance is another. The process demands a robust supply chain, advanced robotics expertise, and significant capital investment. Sourcing the specialized components such as precision actuators, sensors, and hydrogen systems at scale while keeping quality intact is a complex task that Kawasaki must solve. Cost remains another critical hurdle. The Corleo's high-end engineering, combined with the use of hydrogen fuel cells and advanced mobility systems, makes it expensive to build. To make it viable for large-scale applications in cost-sensitive industries like agriculture or logistics, Kawasaki must find ways to reduce manufacturing costs without sacrificing durability or performance. Streamlining production, exploring economies of scale, and possibly collaborating with suppliers will be essential steps in making the robot financially accessible. Another major consideration is the hydrogen infrastructure. While hydrogen offers a clean and efficient energy source, the global network of refueling stations is still limited. Unlike electric charging stations, which have seen rapid deployment, hydrogen stations are scarce and often concentrated in select regions. For the Corleo to operate at scale, Kawasaki will need to work closely with energy providers and government bodies to help build and expand this network. The success of hydrogen-powered mobility may depend as much on infrastructure as on innovation. The Corleo must also prove its resilience under real-world conditions. While designed to handle tough terrain and demanding tasks, it needs rigorous testing in a variety of environments to validate its long-term reliability and safety. A single high-profile failure could hurt both the robot's reputation and public confidence. Durability, ease of maintenance, and consistent performance under stress will be critical factors for its success in commercial or industrial settings. Public perception could also influence the robot's trajectory. Though the concept of a hydrogen-powered robotic vehicle is groundbreaking, it may take time for people to accept it as practical. Industries tend to adopt new technologies cautiously, especially those involving high costs or operational shifts. To overcome skepticism, Kawasaki must demonstrate the Corleo's capabilities through pilot programs, partnerships, and real-world applications that showcase its value. Convincing stakeholders of its efficiency and reliability will be crucial for market adoption. Choosing hydrogen over batteries sets the Corleo apart from many emerging robotic platforms. Hydrogen fuel cells generate electricity through a chemical reaction between hydrogen and oxygen, with water vapor as the only emission. This makes it an exceptionally clean power source. In contrast to batteries, which can be heavy and limited by charge cycles, hydrogen systems provide higher energy density. That translates to longer operating times and faster refueling, key advantages in settings where downtime is costly or dangerous. For tasks in isolated areas where power grids are unavailable, the Corleo offers autonomy and endurance unmatched by electric alternatives. It can travel up to 150 miles on a single hydrogen refill, comparable to, or better than, many electric vehicles in its class. And as hydrogen infrastructure gradually expands, these robots could be deployed more widely, offering new solutions in sectors from environmental monitoring to supply chain logistics. Despite the promise, hydrogen still lags behind in terms of mainstream adoption. Electric vehicles have benefited from massive investment, consumer familiarity, and infrastructure development. Hydrogen, by comparison, has seen slower uptake due to higher costs and fewer refueling options. Yet, the Corleo could become a catalyst for change. If Kawasaki succeeds in proving that hydrogen-powered robotics can be efficient, durable, and economically viable, other companies may follow suit, accelerating adoption across industries. The Corleo is more than just a concept. It's a glimpse into the possible future of sustainable mobility. Its clean energy, off-road capability, and multi-sector potential make it an exciting innovation. But transforming it from an experimental robot to a global solution will require time, strategic partnerships, and a serious commitment to infrastructure. The path ahead won't be easy, but if successful, the Corleo could redefine what we expect from both robotics and green transportation. Kawasaki's Corleo robot vehicle is a bold step toward redefining mobility. Designed to navigate challenging terrain and perform complex movements, it presents a compelling vision for the future of transportation and robotics. However, the leap from prototype to real-world deployment involves far more than technological novelty. It demands unwavering durability, public trust, and a competitive edge in an evolving market. Before this machine can gain widespread traction, it must prove its resilience. Though the Corleo has demonstrated agility and versatility, Kawasaki must rigorously test it in harsh and unpredictable environments. Any operational failure in a high-stakes scenario, whether in disaster relief, tourism, or agriculture, could undermine confidence in its performance and tarnish its reputation. Public perception will also play a pivotal role in determining the Corleo's success. While its innovative design captures attention, the idea of a hydrogen-powered quadruped robot replacing conventional vehicles is still unfamiliar to most. Acceptance won't come automatically. Kawasaki must actively engage the public, showcase its capabilities through demonstrations, and partner with relevant industries to highlight real-world benefits. This educational effort will be essential to building trust and interest. Kawasaki isn't the only player in this space. The competitive landscape is growing rapidly, with several companies making strides in both robotics and sustainable energy-powered transportation. Boston Dynamics, for instance, has already made waves with its agile robots. Though their focus has largely been on electric-powered machines like the Spot robot, the buzz around robotic mobility is expanding, and Kawasaki must carve out a distinct identity for the Corleo amidst this surge. In the hydrogen vehicle sector, major automakers like Toyota and Honda have years of experience. While they've primarily focused on passenger cars, their hydrogen fuel cell innovations could easily cross into robotics. If these industry giants pivot toward mobile robotic platforms, Kawasaki will need to maintain its lead with ongoing innovation and strategic partnerships. The rise of electric vehicles adds further pressure. EVs are backed by a mature infrastructure, growing consumer familiarity, and strong government incentives. While hydrogen-powered machines like the Corleo boast advantages such as longer range and faster refueling, they still face the challenge of operating in a world designed around electric charging networks. To gain traction, Kawasaki must work with policymakers and energy providers to help build a broader hydrogen refueling infrastructure, especially in areas where such technology is nearly non-existent. Affordability is another pressing concern. The Corleo's advanced sensors, robotics, and hydrogen-powered engine make it costly to produce. For it to see mainstream adoption in industries like logistics, tourism, or agriculture, Kawasaki must bring down manufacturing costs without compromising performance or quality. Streamlining production, optimizing the supply chain, and investing in scalable technologies will be critical to this effort. Shifting from a single showcase model to a full production line is a massive undertaking. It requires refining manufacturing processes and securing a consistent flow of specialized components. This includes hydrogen fuel cells, which are still relatively rare and expensive. Ensuring a reliable, cost-efficient supply chain is essential to meeting future demand. As Kawasaki continues development, new players are emerging with competing visions. Companies integrating AI, machine learning, and autonomous navigation into their robots are quickly narrowing the gap. Some of these startups and tech giants may not have entered the hydrogen-powered space yet, but their rapid pace of innovation suggests they could soon pose serious competition. Kawasaki must remain agile, iterating quickly and staying ahead in performance, sustainability, and usability. Despite these challenges, the Corleo's potential remains substantial. It could reshape how we think about mobility across remote, hazardous, or off-grid environments. Its long operating range and clean energy profile give it a unique position in the growing push for sustainable transport solutions. Yet its success will ultimately depend on Kawasaki's ability to adapt, scale, and connect with users. The Corleo must not only impress in controlled environments, but also prove indispensable in practical applications. Whether rescuing people in disaster zones, transporting goods through rough terrain, or offering tourists an unforgettable off-road adventure, its value lies in how well it performs, where traditional vehicles fall short. The competition is fierce, and the technology is evolving fast. But if Kawasaki can meet the challenges of production, infrastructure, cost, and public engagement, the Corleo could become far more than a prototype. It might just lead a new era of robotic mobility powered by hydrogen. Whether it becomes a game changer or just another promising concept will depend on the decisions made in the next few years. If you enjoyed this video, don't forget to like, share, and leave a comment with your thoughts. Make sure to subscribe and hit the bell icon so you never miss the latest in tech and robotics.